Good stuff. Thanks again, and hello, fellow data modelers, and welcome to this session on data vault and business modeling. But what we're really talking about is information modeling. So I'd like to start with a quick thought experiment, which is courtesy of Lars Grunbeck, which most of you would know of anchor modeling fame. So Lars has written some really good papers about what it means to describe reality, and I really recommend having a look at his materials when you have a moment. So imagine there's this thing here. What could it be, right? Shall we just, I don't know, call it an orange dot? And where did it go? It must be around somewhere, don't you think? Now it's gone. And we could argue that the thing, it used to be there, right? So where the pointer points at, but how do we know? And it's interesting to consider that we can only know this if we have a record that captured its earlier existence somewhere. In our case, we can navigate a few slides back, and well, most of you would remember if been paying attention or don't drop in too late, right? But we can really only assert that this thing existed by comparing it to a state in the past that we've recorded somewhere. And hold on now, so now this thing is back. But is it though? Is it really the same thing we're talking about? How can we be really sure? We can't be really sure that it's exactly the same thing, right? We have to be able to uniquely identify it. And once we identify it, can we match it against our existing records so we're sure that it actually is the same thing, right? And what kind of properties would be different if we do this comparison? The only properties that we know about this thing is that it's round, it's orange, and it pops in and out of existence, like an electron, right? This is how we can start to describe this thing. But I'm saying, orange. Are we really sure we can classify this thing as orange? What does the color of orange really mean to us? And are we sufficiently precise in our definition of what orange is? And are we on the same page about it? Because modeling is about communication at least as much as it is about anything. So maybe we should have a closer look. And then it starts to be more familiar. Or does it? And are the properties different? Is the meaning of the thing different now? So this introduction about modeling reality, as per the great papers of Lars here, it explains, or it's a nice introduction, that accurately capturing reality in a model is not an easy thing. A model at the best of times is an abstracted representation of reality, and we keep on trying to find the right way to describe this reality for our purposes and for the things we seek out to achieve. And this is assuming things will stay the same and that our reality is relatively stable. And even if we do agree what this thing is at the point in time, this is also likely to change. And I've got this example here that I have, and Remco, I don't have the party example here. I've got a Genesis example, because if we talk about Genesis, and you might have seen, they just had their last show a couple of weeks ago, which they look really old, by the way. But they've been with most of us in our young years, formative years, adult years, right? They've been around forever, basically. It's one of those standard things in life. But they used to start as this experimental rock band with Peter Gabriel here, with all kinds of weird and wonderful wigs and costumes and stuff like that. But over the years, Phil Collins here took over the singing and ultimately left on to have his solo career. And I remember being in Cologne, and he had this stadium filled out 5 days in a row, which I thought was really impressive for a solo guy, right? But he was so busy doing that Ray Wilson here from Stillskin took over the work. And ultimately they got back together and they just had their final tour. But if you talk about what Genesis is at this point in time, you might get very different answers depending on sort of what your age is and what your interest is in what kind of music. And the moment that you associate it with has a very different meaning for different people. And, it's the same for Metallica, right? Similar story. You've got on the top left here, Dave Mustaine, working with James Hetfield, creating metal. And, Dave Mustaine, as we all know, went on to found Megadeth, and Metallica went off with Ride the Lightning, changed bass players, unfortunately, for them, because one of them passed away, but ultimately found another bass player. And they're touring still. Not in Australia, unfortunately. That for some reason does not seem to happen. Anyway, point here is that when describing reality, creating a model, there's often more than meets the eye, and your vantage point, your perspective, often strongly influences the outcome. And these vantage points, which are the levels of abstraction and more generally the way you approach certain situations, can result in the same thing being modeled in very different ways. And that's what today's session will be all about what it means when you apply different modeling perspectives, in this case to a data vault model. So I'm Roelant Vos, and I work as a data specialist, and I call myself an automation enthusiast, mostly because I like coding and generation and forward engineering stuff. And I've been working in the data area for a while in different roles, as a consultant, as a trainer, as a manager, and now as a software developer. And the concept of data solution automation, so the ability to forward engineer data solutions and put these in DevOps processes and pipelines and make everything run automatically, that has been a consistent factor throughout these years. So it sort of makes sense that these days I'm working for a software vendor, Varigence, which specializes in data warehouse automation. And you may have heard of BIML, the BI markup language, especially if you've been active in the Microsoft data stack. So BIML is an XML-based domain-specific language that you can use to describe your data structures and your data logistics processes, your whole data flow, if you like. And it comes with a compiler that picks up this language and compiles it into outputs such as tables and data logistics artifacts and whatever it is you want to generate. So BimlFlex, the tool that we built, is a framework around that language, and it allows you to manage your solutions and forward engineer that into a number of different types of data logistics for a variety of architectures. But today it's not a software demo. And there's plenty of content covering how we as a vendor tackle these things on a YouTube channel. So of course, I'd like to invite you to have a look, but that's not what today is all about. But the concepts we'll discuss now are related in a way, because what we've implemented in BimlFlex is what we call the business modeling feature. And I don't want to go into too much detail about what that is, but it is relevant today because you can imagine, for me as a software vendor, we always try to strike this balance between enabling our users to implement their own philosophies and standard and also provide standard templates and patterns out of the box. And nowhere does this friction come up as often as when you're talking about data vault. While you can generate a data vault at the click of a button, we feel it's in everybody's best interest to explore various alternatives. And what is a good data vault for one person might not resonate as well with another. And different views on how to do things, they show up all the time. And on top of that, you also need to take into account different styles of development and approaches. Do we start creating things right off the bat and are okay with refactoring the whole thing? Or do we spend a little bit more time up front and create a more holistic model? Those approaches, they will have different effects on your end result. And the examples I will walk through today in this session are a result of basically our efforts to explain the consequences of these different approaches. And I like to think of this in terms of options and considerations. And it's not about good or bad, it's about understanding the situation and the reason and the purpose you're doing certain things, so you can define your approach with eyes wide open. And as a software product, we seek to make sure people can do what they think is best, at the same time provide some guidance about what we consider a good practice to develop these kinds of applications. So you don't want to limit people, but you also want to guide a little bit. And it's a careful balance. And as I said, Data Vault always makes that really interesting. So when it comes to modeling, change is an important factor to consider. As we've seen in the introduction, sadly, nothing truly is forever. And if we look at the systems we use in our business, the operational systems, so the applications you use to run your everyday operation, they evolve over time, right? You get new ERP systems, you get new policy management systems, you get new CRM systems. So the systems, they keep on being added to your data landscape. Business models, they also evolve over time. However, the business processes, they don't tend to evolve quite as fast as the system landscapes do. So if you model with the business terms and processes in mind, your model will tend to evolve at a comparatively slower pace. And because of this, people agree that forming a conceptual sort of business view of the data is a good starting point for any data initiative. Yep. So Remco, I see that. So change is the only constant, right? That's the phrase. So at some point, you need to be mindful to select the right level of abstraction for your model. So your vantage point. And with so many flavors of Data Vault going around, we believe that using structured business modeling techniques is the way to get the most meaningful Data Vault solution for your purposes. This is because adopting a business model helps to reduce the bias that can creep into some designs. When your design is based too much on specific operational systems and how they call and do things, basically. At the same time, you still apply the same concept you're familiar with. So you need to solve the same types of problems, just in slightly different ways. And the solving of those problems is different, easier or harder, depending on which perspective you take. And that said, it will be easier to integrate new systems, new operational systems, because they would follow the same concept, at least largely, even though they may use different names for things. The principle is that if new systems come in, we can map them to existing business concepts more easily. So let's get started, right? I've seen a lot of Data Vaults, and for all kinds of reasons we probably are aware of, there's many interpretations going around. But an important early point to make is that the structure of a data solution by itself does not necessarily say that much. But I'd like to keep that in mind for the different examples that I'm going to go through in the next few slides. And you may have heard about the duck test, right? So if it quacks like a duck, if it walks like a duck, it's probably swims like a duck, it's probably a duck. In this particular case, if it looks like a Data Vault model, and it's structurally and everything, it doesn't mean that the overall solution necessarily qualifies as a Data Vault-based data warehouse. Having a certain model structure does not necessarily mean that a given methodology is implemented correctly. Or in other words, the model structure itself does not mean being compliant with certain concepts of the methodology. And this is one of the things that we see from time to time, and we try to explain and capture in our tool. The fact that you can generate a Data Vault doesn't mean your data warehouse ticks all the required boxes. And I'll show you with a couple of examples. So then, what is a data warehouse? And when it comes to defining what a data warehouse is, because we're talking about ticking the boxes for data warehouse requirements, and I'll go back to the original definition as provided by Bill Inman. There's many around. This one seems to remain the most popular, and it definitely serves our purpose for today. So in this definition, the main themes are that the data warehouse is subject-oriented, meaning that the data is organized for a specific subject area or goal, as opposed to based how the operational systems that provide the data organize it. We've got integrated, which covers consistency in conventions, the ability to bring disparate data sets together, stuff like that. We have non-volatile, which means that the data is not modified once it's being processed into the data solution. And we have time variant, which means that the data contains an element of time and can be analyzed using time series. So if we take these criteria into account, it's interesting to think about how these requirements for data warehousing, how these apply to your model when you take these different vantage points to define your data vault. And let's take an example. Let's say, for the purpose of our modeling scenario, there are 3 operational systems involved in a new data solution initiative. In this case, it's for a fast-moving consumer goods company. Should have take a shorter name for that. You have a human resources system that organizes employee records for the store, right? So HR. The administration in this HR system is done by employee ID, and an employee is related to a store. So from the day-to-day work within the HR department, that's what they're used to, right? They work with employees and they work with stores as the central concepts to know what to do with and how to work with. You also have this operation system, this asset management system, that is used to look up the various brick and mortar assets, so the buildings, right? And to use that to manage the leases, the maintenance, the general upkeep. So operations is primarily focused on building maintenance for the purposes of this case, right? And within operations, they would refer to their assets, sometimes as branches. These branches are uniquely numbered in the AMS, in your system, and are referenced when there's a delivery or there's a maintenance job or something like that, right? The light goes out, the elevator doesn't work, stuff like that. And last but not least, there's also a finance system that manages the general ledger, expenses, balances, budgets, forecasting scenarios. Those kinds of things would be tracked at account code level. So finance would work with general ledger account codes that identify costs and profits at store level. So basically here we are, right? We have 3 systems that you can feel they've got a relationship in terms of the things they're doing, but they're working differently, right? They've got different purposes. They're good at what they do, but we still need to try to integrate it into a data vault. And to make things more interesting, when it is time for resource planning, HR provides operations an Excel sheet, the famous Excel sheet that maps employees to an asset. And it's one of those things that you see in every company, right? These are these semi-formal processes. In this particular one, it's not maintained by HR. It's not really in the operation systems, but HR owns the process. But the only people that are aware of this is the team itself, right? But these Excel sheets, you've seen them flying around the organization, no doubt. And there's also IT interfaces, right? So for example, you can have this system interface from finance to operations, right? The little dog icon here, which is developed by IT and make sure that each account can be mapped to an asset. This will be recorded in the operation system as a free format notes field that can be used for reference if cost attributions need to be discussed with finance. So if there's something, imagine this, and these are things that I've seen before. These are actually, as you can imagine, things that have been drawn from experience, right? These interfaces, they don't really have a place to put the data or the information in the system, so they just use free text. And that's what happens here. So what to do? There's no real way to relate accounts to source, so from finance to HR, which can make it hard to manage expenses at a detailed level, for example. But as a data solution, as a data warehouse in this case, we want to be able to do things like these. So let's see if we can build a data vault. Now, I've talked about vantage points or perspectives in the introduction of this session, right? And these options that you would have at a high level, they would be looking at the available data and structures of your operational systems. which I would call source-based. And source-based, it's really popular by software vendors and us including, because you can point at a model. It's like a source physical model, if you like, right, from the operational system, and you can generate what looks like a data vault using the available references, right, the primary key information, for key reference and stuff like that. So you can look at the structure, the physical structure, and turn it into a data vault model. But because of this, the model you would get would be strongly biased by how your system organizes its data. And following this approach tends to be handicapped in its ability to manage changes, which we'll see in a bit. Right? Not saying it's bad, but it's saying you get quick results, but you're going to struggle at some point managing the changes in your system landscape. Alternatively, some organizations use industry reference models. So option 2, to kickstart their effort, their modeling. And these industry models, they tend to be more generic and abstract and use terms and definitions which may not always align to how your company refers to things. Right? It's a different vocabulary. Doesn't really resonate always at the same way with everybody. And of course, you can use different levels of abstraction, or you can consider using different levels of abstraction, I should say. But in most cases, the resulting models tend to be more generic, using less familiar names. And this approach can lead to issues in delivering the data, as we will see later. Again, not saying it's bad, but it's being aware of what the consequences are for certain actions. And last, another approach is to workshop a model drawing from the collective understanding of the business and its processes, so the people involved in the day-to-day work, getting the information out of their brains, putting it into a resulting business model, which is more likely to contain definitions and terms you're familiar with and are meaningful, at least to the involved teams, right? So your mileage may vary. It depends on who's involved. Very important. But the people that are involved with the workshops, which ideally are cross-domain, they would leave these workshops with a sense like, yep, we're on the same page there. And these models, they tend to be a bit more stable because they're modeled after the business processes as perceived by the people involved with that exercise, and they don't tend to evolve as fast as the operational systems do. And now we have the introduction of what the data warehouse criteria are and the different starting points. We can have a look at how the data vault will be different. So let's have a look at the source-based model. So in this source-based approach, or the bottom-up approach, if you like, you would use the available data, so the primary key, foreign key references, all that stuff, to derive a model for a specific methodology, such as data vault. Basically, what we're doing is we're taking a source and we're representing a data vault version of this source. And the added value may be limited. It might be more effective to work with persistent staging area, for example. But then again, there are some advantages as well. If we pick the data from these systems, it would look a bit like this. So store and employee can be created as a hub store, hub employee with their descriptive contextual entities, right, satellites, and a relationship between them, because we know this relationship exists in the source. But just looking at the source, we can derive or we can infer this as an outcome. And the same applies for finance and for operations. There's no systematic way at this stage to relate an account from finance, right, so the hub account, to either store or branch or employee. So is it subject oriented or integrated? Not really, right? For the reason I just mentioned, these are effectively data vault versions of the source model. that don't really have a relationship with each other. However, we do apply the standard data vault patterns. So we apply the load date timestamp, and we store information in time, at least from this technical timeline. So we do satisfy this non-volatility and time fairness requirement, arguably. Now, I did talk in the introduction in the case that we have some interfaces, right? So with a bit of effort, if we take into account the relationship between store and branch, we can look at the Excel sheet, right? So if we say this Excel sheet that HR manages, if we accept it as a data source, we can establish some relationship. And if we're okay to do some parsing of some free text, you know, in the free format notes field in the operation system, we can also establish a relationship that exists. So let's have a look. And the model would look like this. So now with the three systems and their sort of formalish and semi-formal interfaces between them, we can build these relationships with a bit of effort. However, you can imagine that if the HR system changes, the impact on this model is quite significant. So what used to be a store concept, it might be called something different in the new system. And do we still want to map it to the store, right? Or do we create a new hub and a new link? Either way, it's still arguably not really integrated. So each concept in each system is still modeled as its own hub entity. Like Shane says in the chat, it's a fancy staging area, right? So yeah, if it works, it really depends on how comfortable you are with Excel sheets and flat files, right? So it's something to bear in mind. So keep this, have a last look at this slide, and then we go take the step back and look at the industry reference models. Now, if you look for a top-down approach for modeling, there's a lot of reference models that you can adopt to kickstart your data modeling, right? And they do come in all kinds of shapes and sizes, and maybe colors too. I mean, you can get them through software vendors. You can buy them. They are described in data modeling books. They can be purchased either as part of a consultancy package or as part of a model or a product. In many cases, these are defined in a more abstract way and typically are used to provide a more conceptual description of the business. And using industry reference models may lead to a solution that is not always as meaningful for the team working with the model. Because, you know, it can sometimes be hard to visualize exactly how to map your data to these, to these high-level concepts. And while reference models are carefully crafted to describe a certain type of company, the way it does so may not necessarily align to all companies, right? So your company might have implemented things slightly differently, you know, to get an edge on the competition, or just to, you know, because of historical reasons, whatever it is, it may not always fit well. So usually a lot of effort goes into molding those reference models into something that is closer to what you're trying to do. Now, arguably, and I will get back to this, right? But party is like a super high level of abstraction. But you know, for argument's sake, let's see what happens if we take this approach, right? So a party can be modeled as a hub party, and it has a set, right? So it is some context that describes the party, and we can have a two-way link, a relationship, self-referencing that also has some contextual information that describes it, right? And of course, there's other ways to do the same thing, right? You can also have a separate hub for that, but for all intents and purposes, it could look like this. And for data vault, these abstract terms, you know, you don't really want to super type things at this level, right? So subtyping and super typing in data vault is not recommended at the best of times. So in data vault, you want to avoid it as much as you can. But if your level of abstraction is too high, and that's the message here, for example, using party, arrangement, surface, you will likely run into a lot of complex role playing for relationships, and which makes it hard to get the data out of the model. So as I said in the introduction, the handicap of this particular model is that it's harder to get the data out. And it's because you can't really tell, looking for the model, what's really happening. You know, is a relationship between party and arrangement, is that a working arrangement? Is the building lease? Is the relationship between party and party that we see here, is that between an employee and a manager? Or is that between a service agent and a customer? So you have all these types of relationships that you need to infer from looking at the data, and you have to query the data to understand what's really happening. It's not immediately visible looking at the model what's happening here. So we don't really know if account and store exist in this model. You would have to query the data to know. And as I said, because the relationship carries so many different meanings and there's so much role playing going on, extracting the data is hard because you get this complex query with all these self-references. And, you know, I think we can all agree the model itself doesn't read as well. It's not really clear what's going on here. And I do admit the party level is arguably, you know, one of the highest and therefore less useful levels of abstraction for a physical model. But you see what I mean, right? So you have to, if you limit your objects too much and you take this high vantage point, you'll get into trouble trying to get the information out. But as I said, there's many levels of abstraction possible, and there may be cases when a common model exists for different systems. For example, the Dataverse and Microsoft, and there's so many good reference models available. If you haven't looked into them, it's worth having a look. The modeling resource books by Len Silverstone, and you can use those for inspiration and then make it your own for your model. And you know, these books, they're pretty good. I get a lot of inspiration out of them. If you work in different business, at least you get a sense of what kind of stuff people are talking about. And you can also use it in business modeling workshops if you want, right? So these things are not exclusive. For now, though, the data vault would still be non-volatile and time variant, right? We still apply the same data vault patterns. So the book is the data modeling resource books. So volume 1, 2, and 3. It's like a phone library for data models by Len Silverstone, also known as ZenLen. For now, yeah, so non-volatile time variant, but the integration is maybe there, right? Arguably, although we're not really sure, right? Do we have the fact that we have the same things in the one table is really integrated? We don't really know. So it's arguable, and the same is being subject oriented. And you know, and Shane beat me to it, but we could just call it a thing, and it would be giving us the same results. Right. To avoid introducing a bias for the way model objects, relationships, columns are named, and to be sufficiently precise with regard to the terms that we're using, a lot of organizations choose to start their data solution initiative with a series of workshops that attempt to capture the essence of the information that is used. And that's what the business modeling workshops is. So business modeling, they identify what type of things are being used in the business, how these things interact with each other, and it also helps to define ways to uniquely identify these, these things unrelated to how this is technically implemented in the operational system. And there's plenty of structured approaches available with ensemble logic modeling, ELM, as advocated by Hans Hultgen and Remco Broekmans, as here in the audience today. That's probably the best known one and a really well structured one. Other approaches are related to factor-oriented modeling, which is also interesting. Capture natural language to define an information model. Either way, having a structured approach is what helps you to get from the reality into something that is abstract at a sufficient level to create a physical model such as a data vault from. And in the software that we sell, the BimlFlex suite, we continue to work to support this so we can use the output of that modeling to generate everything we need to run with it, right? And that's where my interest comes from. I want to make sure that whatever we get out of this effort can be forward engineered. And by doing that, we will continue to be able to generate code at a more abstract level. Ideally, we would have a workshop, press the button, and everything is just there. And if we change the model, we press the button and everything will be forward engineered again. That's what we want. So, business modeling. By initially discussing more generic definitions and terms, considering the business process, we can create a model that is somewhat elevated from the way the data is available in the operational systems. And as you can see on the screen here, I put employee and branch and account and store, which are the terms that are used. And we want to make this specific to the business that we have. We want to use terms that are familiar and meaningful to the people that work there. And even though this will change over time, like I said, it's expected that the change will be slower. So what happens, right? So we can discuss with everybody in place that store and branch really are the same thing, even though they're described as something different in the systems. We can also say that account maps to branch the same way. So we need to figure out what the synonyms are and to find a term that we are all happy with and that we can refer to and use as common language going forward. Functionally, it's all the same, but acknowledging this makes the model, the data vault model, yet again look really different. So account and store are integrated into the branch concept, and both data sets load into this branch entity now. And by making this modeling decision, we are automatically setting up the physical model and the data loading processes or the data logistics to populate it, to point at the same target, right? Which is a concept we call passive integration. If we define this as a data vault, it would look like this. If we want the context, the descriptive information, it can still be separated in the data vault so that the original data is preserved for each system that provides the data. But in this particular case, everything is integrated on this branch business concept that we instantiate as a hub branch. And the result is that you are more subject oriented because you're integrating your data around agreed concepts. And the passive integration already alludes to the integration aspect, and we still know volatile time variant because we still apply the load date timestamp and the time series and stuff like that. So this third approach gives us yet another model, which arguably is closer to how we want to work with the information. So we've got three different approaches, three different data vaults, all from the same data sets, just by looking at it from a different perspective. Let me see. So let me go to the next slide here. So this is what you see here is basically the same model we got from the business modeling exercise. And the reason I've added this slide is that I wanted to compare it to the first one, just because it's fun. So the data sources remain the same, but I just want to compare it and have a look. Spend a lot of time animating all of this, so at least I need to run it past you guys. But this is the difference between the business model and the source model, right? So more objects, harder to manage change, and arguably a bit harder to get the information out of as well. From here, we can still make interpretations on what is basically still the raw data, although modeled or organized in a slightly better way to get the information we need. And this is where I guess the the concept of the business data vault comes in, and it's not a very helpful term, but I wanted to discuss it anyway because everything we've done, including the business modeling, means that the first step of getting your information in the same place is a bit easier. But we're still, and again, I've got the business model outcome here. This is still, technically speaking, quote unquote raw data vault because we've modeled the right business concepts and instantiated the right entities, and now we map the information to it. But it's still the raw data for all intents and purposes. And this is where we can start to move to add things and go from raw to business if you want, right? So on this foundation, you start to add more, you layer on more transformations that use the data that's available to get alternative interpretations on the data that you have. So the application of the quote unquote destructive transformations or business logic, if you want a friendlier term, that's what you can then start adding on to this. So I just wanted to clarify because in a lot of cases the business modeling is associated with, well, I'm pretty much done, right? But I wanted to make it clear these are variations of the same theme that will get you to a point when you can start layering these transformations on there as well. Yeah, so how do we do business modeling? I created a really short primer, and I know we only have a couple of minutes left. I only need like 3 minutes. And I just wanted to run through a couple of slides which I've automated, so I don't have to talk as much. But it's basically based on the ELM approach, right? So it's sort of my takeaway that if you want to try your hand at business modeling using ELM, this is how that would work. So you would capture everything on a canvas, right? The proverbial post-its and stuff like that. You would associate it with events and say these concepts are related to this thing that's happening. And you would use that to create your diagrams. And again, ELM provides all kinds of templates and structured approaches to work through that process. And it looks a bit like this. So first, we just capture everything. So we make a canvas and we can use these swim lanes, however we want to, and we start talking to the business and talking to everybody involved and just putting everything on the canvas. Then we're going to remove the synonyms or deduplicate. So we would go and remove it. So we would say, this is this one, whatever it was, it's known as this one, and so forth, right? So we start to create like a survivorship of terms, and we agree on what the surviving terms is for things that are actually the same. Then we're going to see which things we've put on the wall or the swim lane are actually attributes or properties of a thing. So we're going to say these are properties of something else. Then we can look at each event and see which business concepts are actually involved with this particular event and or business process. So we pick one of these events and then we start removing the ones we don't need. And if we want to, we can then split it up into like a parent-child or master-header relationship and move things around on the canvas. And again, you can use a tool for this, you can use post-its for this, but the approach is the same. Once we have that, we can use that the resulting output of that workshop exercise is basically an initial model. And then we can start adding relationships that we've missed or that are, what is ELM called natural relationships. So things that are not necessarily directly related to an event, but they still have a relationship. And we can add these objects here and then complete the model. And with this model, we then map the data sources and then forward engineer the result. That's the theory, and that's what the structured approach of ELM and business modeling can do. And we recommend having a look. So that about wraps things up because we're also out of time. I just wanted to say, as always, thanks for your attention, right? Because I always really appreciate the time and the opportunity to discuss these things with you, right? My peers in the data modeling space. And of course, the details are on the slide deck. And please reach out if I can explain a bit more or you want to go deeper into a couple of topics. To summarize, we've looked at different approaches towards modeling reality. And we've looked at how different vantage points give you a different data vault solution using the same source data. Having a business focused view will keep the model manageable. And if you like automation, the next steps would include mapping your data to this model and forward engineer everything into your target environment, look at the result, and then go back for any change to your business model and rinse and repeat. That's the dream. That's what we try to do. So if you want to know more, please reach out anytime. And I want to leave it at this and see if there's any questions or comments or anything, right? So thank you.